In this question, we've been told that an estate agent is studying the cost of office space in London. He takes a random sample of 90 offices and calculates the cost, which is going to be X pounds per square foot. His results are given in the table below. We've been told that a histogram is drawn for these data, and the bar representing 50 to 60 is 2 centimeters wide, 8 centimeters high. We've been asked to calculate the width and the height of the bar representing 20 to 40. Well, these sorts of questions, we always want to draw a visual of the bar that we're working with. Any histogram can be drawn to any scale, any height, any width. So for this particular histogram, we want to find the ratio between the class width and the drawn width, and then the ratio between the frequency density and the drawn height. So the first bar, 50 to 60. That means there's a class width of 10. That's the difference between them, and a drawn width of 2 centimeters. The scale factor here is to divide by 5. For any class width I now calculate, I know if I divide by 5, I will find the drawn width. 10 divided by 5, 2 centimeters. Let's be careful with the class width. Many students aren't really making a good decision on whether to use bounds or not. In this case, I noticed that the upper limit of one interval and the lower limit of the next interval were actually the same number, meaning I didn't need to use any bounds. I didn't need to close the gaps. There was no unaccounted for space in between one interval and the next. So in this case, I didn't need to, but you must always check. Frequency density. We're going to find that by doing the frequency divided by the class width. In this case, 32 divided by the 10 we just found. That gives us a frequency density of 3.2. Now, if the drawn height is 8 centimeters, the scale factor is going to be to multiply by 2.5. I can find that by doing 8 divided by 3.2. 8 divided by 3.2 simplifies to 2.5. Okay, now that I have these scale factors, I'm going to use them for the next bar. The next bar was 20 to 40. The class width is 20, scale factor divided by 5. The drawn width is 4 centimeters. Frequency density, this time round, 12 divided by 20, that gets us 0.6. Apply the scale factor of multiplying by 2.5, and we get a drawn height of 1.5 centimeters. So we use the information about the first bar to find those scale factors, and then we apply the scale factors in any other bars as necessary. Part B of the question asks us to use linear interpolation to estimate the median. We need cumulative frequency to work with interpolation. The median position is going to be 90 divided by 2, the 45th position. We're then just going to check which interval contains the 45th value. That's going to be the interval that matches with the cumulative frequency that first goes above 45. So looking down the list of cumulative frequencies, the first one above 45 is 50. We need to use this interval. Let's set up the diagram. So we know the value we're looking for is somewhere in between 45 and 50. The cumulative frequency goes from 25 to 50, and we're going to need to find the 45th position. Okay, just to make it clear which calculation we're doing, the thick bar will be represented in the numerator, while the entire bar is represented in the denominator. Q2 minus 45 over 50 minus 45 equals 45 minus 25 over 50 minus 25. Rearranging, we get Q2 equals 49. £49 per square foot. That's the median cost of office space in London.